Okay, guys, this topic is extremely important. So whenever you apply differentiation in physics or in much of the sciences, you are actually using something known as implicit differentiation. And let me try to explain to you what is the idea. So first of all, I made a mistake here. It should not be coordinate 5 and 5. So we have a circle, right? And a circle is defined by, in this case, the equation x squared plus y squared equal to 25. It's a circle of radius 5. So the point 5 and 5 obviously is not on that circle. What I meant is the point, this point should be 5 divided by radical 2, 5 divided by radical 2. Good? That's the point I meant here. Good? Nobody is confused? I hope not. Do you understand, guys, what is this equation, right? So I'm not sure, how do you think of it? X squared plus y squared equal to 25. What it means is identify all points. All points are coordinates with an x coordinate and a y coordinate, such that this is the relationship between the two coordinates. Yes? The square of the first coordinate plus the square of the second coordinate equal to 25. Why in this case do I know it defines a circle? Well, because a circle is the set of points equidistant from the center. In this case, if I take the center to be 0, 0, right? And this to be an arbitrary point on the circle, I know by the distance formula, which comes from the Pythagorean theorem, right? Remember the Pythagorean theorem, guys. So by the Pythagorean theorem, I can just draw a right triangle, and we proved it. We proved it together, a right triangle. And by the Pythagorean theorem, we know that this distance, let's call it r equal to the square root of the differences in the x. So it would be x minus 0 squared plus y minus 0 squared, and take the square root, right? And if I square both sides, then I have r squared equal to x squared plus y squared. So I recognize that a number squared equal to x squared plus y squared defines a circle. I hope it's a good reminder, guys, right? You understand how equations are working. That's going to be very important for this chapter. So in this case, r squared is 25. So I recognize that I'm dealing here with a circle of radius 5. Okay, that's how I know the set of all points. So in this case, y and x are in a relationship with respect to one another. And that's an implicit relationship because you do not describe y as a function of x. There is ambiguity. You can see that the circle is a drawing that does not pass the vertical or horizontal line tests, which means I cannot globally or in general define y as a function of x or x as a function of y. Good? But nonetheless, let's say that I look at this point. Again, the coordinates here are 5 over root 2, 5 over root 2, not what I wrote. And I want to find the slope of the tangent line, which means I presume that if I fly to this planet, maybe it's a planet, right? And I land at this point, I will be seeing a straight line. It will look to me like this straight line. As I zoom in, I will not be able to tell the difference between this purple line and the curve. They will look to me the same. Yes? And I want to know what is the slope of that line. Now, because this point is located on the positive y-axis, right? Then I actually can solve explicitly. And here is what I'm going to do. I'm going to find the derivative of this curve explicitly first. Okay, so what do? I want to solve what is y in terms of x. Are you here, guys? You understand? So x squared plus y squared is 25. It means that y squared is 25 minus x squared. And in general, it means that y is either plus or minus the square root of 25. That accounts for the 2 points on the circle. Either y is positive or negative. So do you understand how I solve this equation up to this last line? Yes, guys? And I'm only interested in the positive sense because y is positive. And the square root will give me the positive solution. Good. So I actually see in this formula, in this y squared, when I am zooming in at this point, I can think that this y is y of x, which equals to root of 25 minus x squared. Good? And then I take the derivative. I take the derivative, it's now chain rule. So the derivative of root is 1 over 2 root. The function inside is 25 minus x squared. The derivative of it is minus 2x. So I then look at it, I simplify, I see minus x over root of 25 minus x squared. And look at it, what I pressed in this red box is the same as what y is. So I can write it as minus x over y. Are you with me? And now when I calculate the slope, I'm saying I need the x coordinate of the point at which I'm zooming and the y coordinate of the point at which I'm zooming. And that's not what I wrote over here. The actual ratio would be, the minus x would be actually minus 5 over root 2. That's the x divided by 5 over root 2. Because I made an error. What I wrote there is not quite right. And it still ends up being equal to minus 1. So the slope of that line is minus 1. Okay, you copied it, guys? Understood? You know that my notes are on my website, yes? You are aware that I have a website, yes, guys? And you are aware that my videos are on YouTube, in case you want to watch them. That was okay, so let's move on. Please confirm, up to this point, have you understood my explanation? It's very important. Yes, great. Rafid, what are you worried about? Why would you wish that? Relax, everything's great. Done? So now let's try the lazy way out. Now, what we did here, we first figured out what y equals in terms of x. Now I will pretend that I do that. So you see, I skip the entire process of solving for y, and I pretend I have obtained a formula, but I'm not aware of how it looks. So y is actually a function of x. Are you with me? So in this case, y of x is this formula. But I pretend that I carried out the operation. I'm just not aware of exact formula. That's where the word implicit comes in. Good? So it's y of x here. And now I look at the relationship on the left of x squared plus y squared equal to 25 as actually x squared plus y of x squared. And I here emphasize it's actually, I don't see a y, I see a formula in terms of x. Again, if I solve for the function, I would see this formula. Good? You have to really now apply your imagination. Now I take the derivative of the left. Taking the derivative of the left part, I get 2x. The derivative of x squared is 2x. The derivative of this part, on the other hand, it's 2 times the inner function times the derivative of the inner function. I apply chain rule. I assume this function will be differentiable. The y will be differentiable here. And I write y prime because I do not know the formula, so that's the best I can do. Good? The derivative of 25 is equal to 0. And now see, I have this expression. I can now move the 2x across the equal sign. I obtain minus 2x and divide by 2y. So I have y prime x is minus 2x divided by 2yx. And if I suppress the x here, the answer is minus 2x over 2y or minus x over y. Same exact answer I obtained here. You see, minus x over y. First coordinate minus first coordinate divided by second coordinate. I just bypassed solving anything explicitly. And of course, then if I have those points, I will obtain the same slope. Okay. Any questions before I move to the next part? Do you understand what I did, guys? Right? There are two stages to solving this problem. One stage is to actually find what is y as a function of x, and what I did is I took that step and I entirely bypassed it. I pretended to carry that step through, but I did not actually do it, and still my solution came correct. Here is another example. Find an equation of the tangent line through the point 1, 2 for the curve determined by the equation y squared plus 4x squared equal to 4xy. So again, guys, do you understand? This is a relationship on coordinates. So we can check which points are on the curve and which are not on the curve, even when we do not see the curve explicitly without a picture. So for instance, is the point 0, 0 on the curve? Guys, so you can see that is the point 0, 0 part of the curve. You can see that that 0 squared plus 4 times 0 squared equals to 4 times 0 times 0, which means that 0, 0 is on the curve. Yes? Is the point 1, 1 on the curve? Or let's say 1, 2. Or I already asked for 1, 2. But what about the point 3, 1? Is the point 3, 1 on the curve? Let's check. So that would mean that the y coordinate, the second coordinate squared, plus 4 times the first coordinate, which is squared with 9, must equal to 4 times 3 times 1. And let's see, so 4 times 9 is already too big, right? So clearly the answer is that this is not on the curve. Do you understand? Without seeing the curve, I see which points are on the curve and which are not on the curve. And now the point 1, 2, as you can verify, is on the curve. And I'm asking you to find the equation of the tangent line at this point. Okay, Nassim, interesting. All right, guys, let's do it. So you had all sorts of interesting solutions. Let's look at this one. So you see, if you look at it carefully, guys, it looks like a perfect square. Do you see that? I can write it as y squared plus 4 plus or minus, better here. Y squared minus 4xy plus 4x squared. That's just a perfect square. Okay, good, Alan. Good. You're right. So it's a perfect square. You all see that? It's just y minus 2x squared, which we have equal to 0. Now, if it equals to 0, that means that y must equal to 2x. So actually, this complicated looking function is nothing more than a line. Y equals to 2x. Are you with me? Do you understand? It's y equals to 2x, and a straight line with will basically everywhere you zoom in will have the same slope. So y prime equals to 2. We are done. The implicit method will be to carry out the calculation. Yes, yes, right. So look at it carefully. If you don't remember how to recognize perfect squares, we'll talk about it later. Okay, guys? It's just a perfect square. Look at it. Whoop, you see it? Whenever you see a mixed x times y and x squared and y squared, you suspect perfect squares right away. Or something similar to a perfect square, okay? So method 2 is implicitly not bothering to solve for y in terms of x, and then I just differentiate. So not bothering to solve means I pretend that I actually bothered, right? Like some people do, they pretend that they did their own work when they actually copied. But in this case, it's actually perfectly great way of cheating. I mean, this one is a smart cheating. So I pretend that I solved for y, but I didn't. And then instead of y, I see a formula in terms of x, right? I see a formula. The formula would have been 2x, but I haven't figured it out, right? So I don't know the formula. So then the derivative of y squared is 2y y prime. It's chain rule. It's a square of some unknown x function. Chain rule. This is what happens here, right? Do you understand, guys, why chain rule here? And then the derivative of 4x squared is 8x. Good? That's just 8x. Now the derivative here necessitates product rule. So it's the derivative of x, so it's 4y, plus the derivative of the y here. So that would be y prime. Next, what I will do is I will bring the y primes all to one side and all the things that have an x to the other side. Good? Good? So we get this solution, then we factor out the y prime. We get 2y minus 4x times y prime is 4y minus 8x. And y prime ends up being this quotient. And if you look at it carefully, the numerator looks like twice the denominator. And again, we get 2. We get that the answer is 2, just like before. And right away, when you say y prime is equal to 2 everywhere for any x, any y, that tells you it must be a line of slope 2. Right? Because that's the only way the derivative is constant. The derivative is constant means that the lines, the tiny microscopic line segments that build up the full curve add together and they are aligned. Good?
A quick question.
Go ahead.
So there was a little, I have a little, like, with my answer, right?
Mm-hmm.
With my solution, right? Is this something still wrong with my, I would say, solution? Because if I just plug in with y is equal to 2, right? We know y is 2. If I plug into 4, it'll still give me 2.
Well, when you say y equal to 2, you have to be careful. We are zooming in on the curve at 2. So y is not always equal to 2. So whenever you do something, ask yourself what's the interpretation of what you are doing. So
Okay.
yeah, so you, James, you were writing, you were doing, let's see. So I see 8x plus 2y y prime. Maybe was it this problem? 1 second. Yeah, so you were doing it, the idea was right, somewhere maybe in the algebra. You can actually plug in afterwards. Once you take the derivative, you can plug y equal to 2 and x
Okay.
equal to 1, and that perfectly works, right? So here is what you can do. Instead of actually solving for x and y, because I'm interested where y is equal to, where is that thing? Where y is equal to 2 and x is equal to 1. Once I'm at this stage, that's, by the way, maybe a good suggestion. Thank you for stopping me there, right? Maybe I can do this. I know once I took the derivative, I know that the y I will obtain will be equal to 2. So this would be 4y prime plus 8, because 8 times 1 equal to 8 plus 4 times y prime, right? If you prefer working with those numbers, then you can then solve for y prime now. Good? For this particular situation.
Okay.
All right, let's go on, guys. I still hope to at least cover the next problem. Okay, so as it happens, most equations that appear when you do some sort of scientific investigation, they will be, the functions will be determined implicitly. They will not be, it will not be a function of something equal to a formula. It will be some sort of relationship like maybe this one, x cubed plus y cubed equal to 6xy. So suppose that your goal was to find an equation of the tangent line to the curve x cubed plus y cubed equal to 6xy. This can still be done using the explicit method. Okay, it can be done. I can show you, if anybody is interested. I can teach you how to solve cubic equations if you're interested. But most likely it will take you a while to understand the solution of cubic equation, and then it will take you a long time to figure it out. Okay, so quadratic equations are many times simpler than cubic equations. Okay, have you ever seen a cubic equation? If you're interested, I'll teach you how to solve one. The history of complex numbers begins with the task of trying to figure the cubic equation. It was a big secret. They used to have not too much to do, so there were competitions. They will come like a math duel, and they will be given some cubic equation, some special cubic equation, and whoever could solve it would get a big prize. Yeah, so one person, actually possibly Cardano wrote it, but I think his name was, they called him the stammerer, Tartaglia or something like that. So he came up with a secret. He figured out how to solve the cubic equation. And here is, guys, the explicit solution. If you actually carry, it will probably take you, I bet, a good hour, if not 2 hours, based on your, how quickly you solve algebra. You might never get there so quickly. So this will be the solution. You see, if I solve for y, that is how the solution will look like. Pretty ugly, yes? And even if I solve it, I still have to differentiate. You understand? Even after solving, that's not my task. My task is to find the derivative at the point 3 and 3. So that is not my solution. I still have to deal with so many ugly things. So you would not want to differentiate it, even if you obtain the formula. So a much nicer thing to do is to imagine that you actually solved. And that's what we do here, you understand? When I begin taking the derivative of the left and right side, I imagine that I actually have a formula instead of y. In this case, the formula would have been this. You understand? So this entire thing is what y is equal to. So you have to have this imagination that, well, you are blind to the solution. Maybe you had a stroke this very moment. So the solution is there, but you're not able to see it. It's outside of your field of vision. Good? So that's when I take the derivative of the left, I see, well, this is x cubed. I have an explicit formula. The derivative is 3x squared. What is the derivative of y cubed? It's 3y squared y prime. You understand where the y prime comes from? Because it's chain rule. It's this thing inside of the cube thing. Right? So it's this entire thing cubed. So there's only x's. You don't see a y. There are only x's. But you don't know what's the formula. So you write 3 times the inner function squared times the derivative of the inner function. You understand where the y prime is coming from, guys? I know Minkowski understands. What about the rest of you? Do you see that? Where the y prime comes? Confirm that you do. It's a very important part of this idea, right? Do you see where the y prime is coming? It's just chain rule, but I do not see the inner formula, so I just say it's the chain rule with the inner formula.
I'm
Okay,
sorry.
guys. Alan says got it. What about the rest of you?
Can you explain it?
Explain what?
The y that I forgot what's the name of that? It's like
Y prime, you mean?
Yeah, y prime. Yeah.
The derivative. It's all I'm saying is this. Also, there is. Look at it. What am I truly seeing? I'm seeing x cubed. I need to differentiate x cubed plus this entire formula cubed.
Okay.
So that would be the derivative of the cube. The derivative of the cube is 3, whatever is inside squared, times the derivative of what's inside, this derivative. Yes? But I haven't bothered obtaining the formula, so I only pretended that I do. So I know it's that formula, derivative of the formula. You understand, James?
Okay.
Right? So in other words, if you did not bother it, then you are not actually seeing this formula. You pretend that you are seeing it, right? It's there because you believe there is a solution. But you do not actually look at it, so you don't know what exactly is going on. Carolina, you get it? Right? You understand? Very important idea, right? I think it's fairly simple. It's just, can you imagine that you know that something is there? It's like I know my cat is right next to me, but I'm not looking at my cat. So I just kind of have a feeling that it's there, that it has a shape, that it's more or less gray, but without looking at something, you don't see the features very well, right? So imagine that you're looking at someone from the corner of your eye. So I'm looking at this formula here and I see it's cubed, but what's cubed I see from the corner of my eye. I don't see it well. I just know there is some kind of very complicated formula, maybe not complicated, but some kind of formula involving x. That's what I'm doing here. And so when I take the derivative, it's 3 inner function squared times the derivative of inner function. And here I have product rule. So it's 6y plus 6xy prime. It's product rule. Understand? There is no y. It's just a symbol. It's your peripheral vision of the formula that you call y. Good? Yes? And so what do I get now? Now I need to gather all the y primes together. So I'm going to gather these on my right. And then so on the right, it will be 3y squared minus 6x y prime. And then I factor out the y prime. So I get this formula. Good? You can, if you want to, at this point, plug in the values for x and y. Yes, exactly, Carolina. I'm treating y as some x expression. Because that's why it's called implicit differentiation, is because in solving the derivative of y, I would first solve for what y is. I would find an explicit formula for what y, and then take the derivative of that. So I bypass the first stage, and I take the derivative pretending that I have the formula. But because I don't have it, actually, I just can write only the derivative of the formula, because I cannot actually explicitly write the derivative. That's exactly right. Okay, so that's why I gave you those examples, because in those examples, I can obtain the actual formula. Here I obtain the actual formula. And the y actually would look like this. It's all very ugly. I would not even want to take the derivative of it even if I had the explicit formula. But here, I hide its ugliness. I cover it underneath a veil. And that's what I have here. So then what is y prime? Look at it, guys. Y prime at 3, 3, I have this formula. You understand? Afterwards, it's just algebra. Once you get this line, it's now algebra. Group together the y primes and solve for y prime in terms of x and y. Naturally, you would not get rid of the y because you don't have the formula. So the solution will be involving the y, the unknown formula, and x. But fortunately, I'm finding the derivative at the point 3, 3. Right? So I know that for whatever the formula is, y will equal to 3 and x will equal to 3. So I plug instead of both y and x at 3, and that's what I obtain. You see this, guys? 6 times 3 minus 3 times 3 squared and divided by the same thing. No, look at it now. 6 times 3, and here you see 6 times 3. You see diagonally. And 3 times 3 squared, 3 times 3 squared. So the numerator is minus the denominator. They are the same except for they have different signs. So the ratio is -1. The slope over there is reduced to -1. You understand? Now let's do a competition. What do you say? Let's see how quickly can you solve a question like this against me. Are you ready? Or you're not in competitive mood? All right, so here we go. Are you ready, guys? Here are some exercises for you to try. Here is one of them. Okay, so here you see most of the equations are so difficult that it's completely not worth the effort of solving the formula, or maybe you will not be able to solve it in any explicit way. So let's see how quickly can you find y prime for this expression. Sine of x plus y equals to y squared cosine x. Ready, set, go. Well, I'm done. How about you? Well, that's good, James. Well, you will see possibly, right? So solve this formula. Would anyone like to see a miserable cat trapped in my room? Okay. Here he was hoping I'm opening the door, but no, it's not opening the door.
Kind of looks a little bit like you.
Yeah, it's very cute. What are you trying to say, Alan? Are you accusing me of bestiality?
No, you're just both you and the cat are handsome looking.
Thank you. I appreciate it. All right, guys. Do you want us to solve it together, or you want to think of it longer? Adding what together? Well, do you want to see the solution, slow motion, or you are done for?
All
right. Let's solve it together. There will be more questions to practice, right? We'll solve this, and then if you want, we can solve a little bit or more after class. Good. So I will clear the board. Okay, guys. So here is the slow motion. No worries, guys. If you see, if you have to go, it's okay, right? We're already exceeding the limit of the lecture. If you have to go, you go, but if not, stay. We'll finish this question. We need to work through it anyhow. So the derivative of the left side is the derivative of sine x plus y. Derivative of right side is of y squared cosine x. What's the derivative of the left side? So derivative of sine is cosine times the derivative of the inner angle, which is 1 plus y prime. Good? You're with me? Good. Now the derivative on the right, it's 2y y prime cosine x plus y squared. Derivative of cosine is minus sine. Yes? So then remember, guys, what is my goal? My goal is to separate the y primes, right? Where do I see a y prime? I see it here, right? I see a y prime right over here. And I see one in here. So to separate, first I distribute the cosine x plus y to 1 and y prime. That's what I do here, because I want to get on the right everything that does not have a y prime. So, and onto the left everything that has a y prime. So look at it. This minus that. So you see cosine x plus y, and I factor the y prime, minus 2y cosine x. That's how I obtain this part. You see, it's this minus this and y prime factor. Do you see it? This line? What is it equal to? It equals to minus y squared sine x minus cosine xy. So this part minus this part. Now that I have the y prime multiplying this expression, I just divide, and I have y prime equal to the right side expression divided by the coefficient of y prime. Good? That's it. That's it. So there will be more problems like this to solve. If you want to, guys, so I'm going to stop the lecture, and if you want to stay a little for office hours, we can practice a few of those questions. And maybe you would like to compete against me, see if you can do it as fast as I do. maybe you'll be fast. Who wants to compete? Okay, I'm stopping the recording.